Hi, my name is Soumya Basu, and I am the CTO and co-founder of bloXroute Labs. So today we're going to talk a little bit about decentralization in Bitcoin and Ethereum. So we did a decentralization study in the course of my PhD studies at Cornell, and we looked at what it means to be decentralized and how Bitcoin and Ethereum are or are not decentralized at the network layer. So why do we care about this whole thing about decentralization? And the real reason is, if you think about what the promise of blockchain is, it's that you can decentralize traditionally centralized things. So for example, instead of trusting the US government for money, you can trust a threshold of miners instead. But if, for example, these systems actually only trust a single miner, then you've essentially recreated a more expensive form of the US dollar with someone that is kind of unknown. The high-level takeaways from this study are that Bitcoin and Ethereum both have some very interesting properties, but they don't quite achieve their original goal of decentralization. And what this really means is that we need to start rethinking these designs in pursuit of better decentralization. So you may have heard of new consensus protocols like Thunder Core, Ethereum's new version Constantinople, or Avalanche. And obviously here at bloXroute, we're doing a major rethink of the network layer. These kinds of points in the design space are important to explore to try and achieve the original promise of decentralization. So the first question we looked at is how much bandwidth is available in the network. What this means is we care about how much data each node can process. And the important part here is the more data each node can process, the more you can the more data you can push through the blockchain. So it's important to set certain parameters like the block size to take full advantage of this. Because if you set your block size to be too low, then you're not taking full advantage of your resources. Whereas if you set your block size to be too high, then you're actually taxing your network too much and bad things can happen. So we see from our graph that Ethereum looks to actually be better parameterized than Bitcoin does, because Ethereum has less available bandwidth than Bitcoin, but Ethereum was able to do about 4 times as many transactions, so about 13 versus 3. Another thing that we see is that Bitcoin's network has actually improved year over year. So we took this measurement twice, one in 2017 and one in 2018. Or 2016 and 2017, and essentially we see that the bandwidth has grown by a factor of 1.7, which means that Bitcoin can increase its bandwidth requirement. So you can either think about increasing the block size or shortening the block interval to take more bandwidth from the network. And another thing to note is whatever bandwidth the underlying network has, the blockchain will cause this bandwidth to be used much more efficiently, since a key idea of blockchain is instead of having the peer-to-peer network do a lot of work, you're actually outsourcing a lot of this work into the BDN. So whatever bandwidth the peer-to-peer network has, a restructuring of the network layer using bloXroute will actually allow us to use this bandwidth significantly more efficiently than prior protocols. The second question we care about is how physically, and by that I mean geographically, decentralized is the peer-to-peer network. So this is the core question behind decentralization. We care about who's using it, who's using each network, and where they are in the world. Are all of the nodes like physically located in one place, or are they sort of spread out quite evenly? And we see from our measurements that Ethereum is actually more physically decentralized than Bitcoin is. And when we dug into sort of why this might be the case, we saw that over half of Bitcoin nodes seem to be in data centers, and over a quarter of Ethereum nodes seem to be in data centers. So basically we see that many more Bitcoin nodes are likely to be located in data centers, so they're probably located much closer to each other than the Ethereum network is. So we actually see that Ethereum is more physically decentralized than Bitcoin. So that's all for part one, where I talked about decentralization at the network layer. Thank you so much for watching, and be sure to tune in for part two, where I continue talking about the results of our study and we talk about decentralization at the mining layer. Thank you all.